الرحمن الرحيم. My dear students, this is the second lecture of applied statistics. In the first lecture we explained the discrete probability distributions, and we said that we have three types of discrete probability distribution. They are the binomial, the Poisson, and the hypergeometric. This is the first one, which is the binomial probability distribution. Okay? The binomial probability distribution is one of the most widely used discrete probability distribution. It's used to calculate the probability that an event or outcome will occur R or X times in any trials or performance of an experiment. Okay? To deal with the binomial probability distribution, the random variable X should be a discrete dichotomous random variable. Okay? This means that each repetition or trial of the experiment must result in one of only two possible outcomes. So the binomial deals with only two possible outcomes. They are the probability of success and the probability of failure. Okay? Only two possible outcomes. Experiments with such a dichotomy of outcomes are numerous. For example, a coin flips results in heads and tails. An election candidate is favored or not. A product is defective or good. And an employee is male or female. Okay? Male, female, boy, girl, and so on. It's traditional to apply the labels success and failure to the two possible outcomes. So in binomial distribution, we have two cases, success and failure, as we said before. Okay? Success not mean success, and the failure not mean a failure. Okay? Success is a name or label for the probability we deal with. The probability we deal with. Okay? The requested probability. Before explaining and applying the binomial experiment or the binomial formula, we need to discuss factorial, combination, and permutation. Okay? Why we need to discuss those three subjects? Because the formula of the binomial contains the combination, and the combinations contains factorials. Okay? And the combination must be different from the permutation. Okay? So the first terminology, which is factorials. Factorial is denoted by symbol factorial. Okay? Read as factorial. The value of the factorial of any number is computed by multiplying all consequent integers beginning with that number to reach 1. Okay, so if we want to get the factorial of 3, you have to multiply 3 by 2 by 1. If we want to get the factorial of 5, multiply 5 by 4 by 3 by 2 by 1, and so on. This factorial you can compute using your calculator. Okay, so n factorial equal n multiplied by n minus 1 by n minus 2 and so on to reach 3, 2, 1. And by definition, factorial 0 or 0 factorial is equal 1. The function factorial means factorial of input, any integer you want. Syntax: f equal factorial n. Description: f equal factorial n means returns the product of all positive integers less than or equal to n. Okay, like this, beginning with n to reach 1. Where n is a non-negative integer value. If n is an array, then f contains the factorial of each value of n. The data type and size of f is the same as that of n. Example 1, find 5 factorial. As we said before, solution by hand, you have to multiply all numbers from 5 to reach 1, like this. So 5 factorial equal 5 multiplied by 4 by 3 by 2 by 1. By MATLAB, using the function factorial, we have n equal 5. This is the number we want to get its factorial. F equal factorial n. This means that we need to get factorial 5 because n equal 5. The result is 120, like this. Okay. Example 2. Evaluate 12 minus 4 factorial. Meaning 12 minus 4 equal 8. So we need to compute 8 factorial using calculator and MATLAB. Okay. Solution by calculator, you have to get 8 factorial, which give you 40,320. Using MATLAB, put n equal 8 and use the command if equal factorial of n. So the result or the answer is the same as that by calculator. Example 3. Evaluate 4 minus 4 factorial. 4 minus 4 equals 0. So we want to get factorial 0 or 0 factorial. We know by definition that 0 factorial equal 1. By hand or by calculator, 4 minus 4 factorial equals 0 factorial equal 1. By MATLAB, n equals 0 and f equal factorial n. The answer is 1. Note that 0 is always equal to 1. 0 factorial by definition equal 1. Combinations means groups. Sometimes we face the problem of selecting a few items denoted by R from a large number of items denoted by N. Okay? For example, a student may be required to attempt 2 questions out of 3 questions in an examination. Okay? So the student must choose 2 questions from 3 questions. The college may need to select 4 professors from 10 to form a committee. Okay? So 4 from 10 to form a committee. How many ways can we make the selections in each case? Okay? This is the meaning of combinations. How many groups? Okay? For this example, how many groups? Every group contains 4 professors selected from 10 professors to form a committee. Okay? How many ways can we make the selections in each case? In the first case, the student can choose questions 1 and 2, or 1 and 3, or 2 and 3. Okay? So we have 3 options, 3 selections. So there are 3 selections called combinations or groups, right? All selections are made without replacement, and each combination contains a different set of questions. It's important to remember that the order in which the selections are made is not important. Why is not important? The selection is important when we deal with permutation, not combination. Okay? Because permutation deals with the rank or the order. Okay? But combination deals with the group at all, the group itself. Okay? So when we say Ali and Ahmed and Muhammad, it's one group. Okay? Whether we arrange Ali the first, Muhammad the second, Ahmed the third, or Ahmed the first, Muhammad the second, Ali the... Okay. All these selections or these groups are the same when dealing with combination. But when dealing with permutation, you will see that Muhammad, Ahmed, Ali is one arranged, Ali, Muhammad, Ahmed is the second one, and so on. So it's important to remember that the order, the arrange, the rank in which the selections are made is not important in the case of combination. It's only important in the case of permutation, not combination. Thus, 1 and 2 is the same as 2 and 1. Both these arrangement from only one form only one combination, one group, 1 and 2 or 2 and 1, Muhammad and Ahmad or Ahmad and Muhammad. They are form one group according to combination. So combinations count the number of ways of choosing R objects from a total of N objects and is denoted by NCR or briefly NR, the formula used to find the total number of combination is NR or NCR equal N factorial divided R factorial multiplied by N minus R factorial. Okay? By definition, NN or NCN equal RR or NCR equal N0 or NC0 equal 1. So we said before that 0 factorial equal 1. 0 factorial equal 1. Here we say that if you select N from N, this represents only one selection. All N from all N. This is one way. There is no other way. One way. The same is when selecting R from R. It's the same as when selecting 0 from N. Okay? 0 from N. This is done by only one way. One way. Where N is always greater than or equal to R. Right? N greater than or equal to R. The function N choose K. It's pronounced as N choose K. It means that you have to choose K from N. K subjects from N subjects. Where N is greater than K. Right? Binomial coefficient of all combinations. The binomial coefficient. So NCR or NR is a coefficient of all combinations when dealing with the binomial probability distribution. Syntax: B equal N choose K, and N is greater than K. So this means that we select K object from N object where N is greater than or equal to K. Description: P equal N choose K, N and K returns the binomial coefficient defined as N factorial divided N minus K factorial multiplied by K factorial. Okay? Just here we replaced R by K. We replaced R by K. Okay? So by hand we know that the computation of combination equal N factorial divided by R factorial multiplied by N minus R factorial. Here we use K instead of R, so the combination is N factorial divided by N minus K factorial multiplied by K factorial. This is the number of combinations of n items taken k at a time. This means that choose or select k from n where n equal to or greater than k. Example 4. How many possible selections exist for a student who is to choose any 2 questions out of 4? So you have to select 2 questions from 4. How many ways you select 2 from 4 questions? By hand, NR or NK or whatever, NCR equal n factorial divided r factorial multiplied by n minus r factorial. So 4C2 or 4(2) equal 4 factorial divided n factorial divided 4 minus n factorial. This is equal 6. By MATLAB, using function n choose k, we have, look, here n equal 4 and r equal 2. Then write the command com equal n choose k, n and r. So n is the larger number and r is the second number which you want to select. You want to select 2 from 4. Okay, the number of ways will be 6, like this. Example 5. 3 professors of a faculty will be randomly selected from 5 professors to form a committee. How many different combinations are possible? Okay, solution by hand. We use the formula of combinations. NR equal n factorial divided r factorial n minus r factorial. So we have 5 professors, n equal 5. So 5C3 equal 5 factorial divided 3 factorial multiplied by 5 minus 3 factorial. Okay, the answer is 10 combinations or 10 selections or 10 ways. By MATLAB, put n equal 5, r equal 3, and com means computation or combination. Okay, so put here any letters you want. Okay, n choose k, n and r equal 10. Permutations. So what's the difference between combinations and permutation? We said that here the order is very important, the rank is very important, but in combination the order is not important. Okay, the concept of permutation is similar to combination, but with one difference. Here the order of selection is very important. So the rank of items or the order of items is the main point when computing with permutation. It's not important when dealing with combinations. To display this difference, assume that there are 3 types of marbles in a jar: red denoted by R, green denoted by G, and yellow denoted by Y. And we want to choose 2 from these 3 marbles. When the order is not important, there are 3 ways or combinations. So if you want to get the number of groups or number of combinations, the order is not important here. Okay? Those three ways are, the three combinations: R and G, R and Y, G and Y. In these three combinations, the order of selection is not important. This means that choosing R and G is the same as G and R. Okay? Choosing R and Y is the same as Y and R, and so on. But when dealing with permutation, R and G is different from G and R. Okay? Now you know the difference between permutation and combination. In these three combinations, the order of selection is not important, and thus RG and GR are representing the same combination or selection or group. Okay? However, if the order is important, then GR or RG are not the same selection, but they are two different selections. Thus, if the order in which the marbles are selected is important, then there are 6 selections called permutation or arrangements. Okay, so the number of permutation is larger than the number of combinations. Okay, as we will see when dealing with permutation now. So permutations give the total selection of R objects from n different objects when the order of selection is important, and it's denoted by NPR. Okay, it's also given in a key in your calculator, so you can compute NCR and NPR from the calculator. The formula of counting the number of permutation is NPR equal n factorial divided n minus r factorial. So because NCR equal n factorial divided r factorial multiplied by n minus r factorial, so here there is no r factorial when using NPR. Okay, so if you multiply NCR by r factorial, okay, you will get NPR. Okay, so NPR can also equal NCR multiplied by r factorial, right? So NPR, number of selection, is greater than NCR by r factorial, because NCR multiplied by r factorials. Okay, so you can say that NCR equal NPR divided by r factorial, right? Okay, NPR also equal n multiplied by n minus 1 by n minus 2 to reach n minus r plus 1. When using combinations, we reach to 3 by 2 by 1. Okay, we reach to when using n factorial, and divided by r factorial n minus r factorials. Okay, so the result here for NPR is multiplying all numbers beginning with n to reach n minus r plus 1. Okay, so NPN equal n factorial, and n factorial equal n multiplied by n minus 1 by n minus 2 to reach 1, or 3 by 2 by 1, as I said. Example 6. A charity has 15 members. They are to choose 3 officeholders, president, secretary, and treasurer, for next 3 years, with the first person selected here. See that the order is important. The order is very important. When the first person selected becomes the president. Okay, the second is secretary, and the third is treasurer. Find the total arrangements of 3 names from these 15 persons. Okay, solution by hand. N equal 15, R equal 3, and the order is very important. So NPR equal n factorial divided n minus I factorial. So n equal 15 divided 15 minus 3 factorial. N factorial means 15 factorial equal 15 multiplied by 14 by 13 to get 3 by 2 by 1. And in the denominator, 15 minus 3 equal 12. Okay, so here you can say that the denominator is 12 factorial. So in the numerator you can say that 15 factorial equal 15 multiplied by 14 multiplied by 13 multiplied by 12 factorial. Okay, why? To omit this 12 factorial with the denominator, which is 12 factorial. Okay, so the answer will be omit this by this. The answer will be 15 multiplied by 14 multiplied by 13. Right? The product of these 3 numbers is 2730. By MATLAB, using the functions n choose k and factorial for the function or the function broad we have, it's better here to use n choose k and factorial. Okay, because the function of permutation give you all permutations for selecting all items, which called perms, and we will see later the meaning of perms. So we can compute permutation using combination and factorial. Okay, let us do that. N equal 15 and R equal 3. Okay, if we divide n choose k by factorial r, because the relation between combination and permutation is, you can say, NPR equal NCR multiplied by R factorial. So also you can use the function n choose k and factorial as you see. So NPR or permutations equal n choose k multiplied by factorial r or r factorial. Okay, so this is the same as NPR equal NCR multiplied by n factorial. Also you can use brood, the function brood. Brood means the product of 13 by 14 by 15, but it's not better. It's better for you to use n choose k divided by factorial n. Okay, so brood here is not important like n choose k and n factorials. The function Burns, as I said, Burns deals with all permutations, all possible permutations. Okay, so syntax P equal Burns V. P equal Burns V returns a matrix containing all permutation of the elements of vector V in reverse lexicographic order. Reverse lexicographic lexicographic, you know, lexicographic means the dictionary. Okay, reverse lexicographic order. Okay, so this means that it's not begin with the first, but it begin with the last one, the last object, the last element. Okay, the permutation will begin with the last one, then the one before the last, then the one before, and so on. It's not begin with the first element or objects. This is the meaning of in reverse lexicographic. Lexicographic means a dictionary. Each row of B contains a different permutation of the n elements. In V, matrix B has the same data type as V, and it has n factorial rows and n columns. Okay, so perms will give you all the permutations in a form of a matrix which contains number of columns and a number of rows. The number of rows equal n factorial, and the number of columns equal n. Okay, so perms will give you n columns and n factorial rows. For example, find and show all permutation of x where x equal 1, 3, 5. Here we want to get all permutations. We have 3 items or 3 objects. Okay? The function berms mean that the permutations begins reversely from 5 to 3 to 1. Okay, this is the mean of reverse lexicographic. Okay, so beginning with 5, the first permutation will be 5, 3, 1, then 5, 1, 3, then 3, 5, 1, then 3, 1, 5, and 1, 3, 5, and 1, 5, 3. 6 selections given in 6 rows and 3 columns. 1 column, 2 columns, 3 columns. Okay, so solution by hand, we want to select 3 from 3, or arrange the 3 elements here, okay, using factorial. So 3 p3 equals 3 factorial equal 3 multiplied by 2 multiplied by 1. So x selections or x groups according to permutation. These permutations are, as we said, here 1, 3, 5, 1, 5, 3, 3, 1, 5, 3, 5, 1, 5, 1, 3, and 5, 3, 1. Okay, by hand we can begin with 1 or with 5 or with 3, but by computer, by MATLAB, it's begin with 5, then 3, then 1. Look at the solution within MATLAB. P equal berms x, and the x equal 1, 3, 5. Okay, look here, the first permutation is 5, 3, 1, then 5, 1, 3, and so on, and so on. Okay, we have 3 columns and 6 rows. 6 rows is the number of permutation. Okay, and this is the details of the 6 permutations, right? So n, which represents the number of columns, equals 3, and ARR, the permutation, equal factorial n, which represent 6 rows. 6 rows. Okay, so the berms deals with all the objects. You want to arrange all the objects, not some objects from a larger number of objects. Okay, so when you want to get the permutation for sum of all, use combination and factorial instead of the MATLAB program. From the above figure, the number of columns equal n or 3, and the number of rows equal n factorial or 3 factorial. So the number of permutations equal the number of rows, which equal factorial n. The binomial experiment. A binomial experiment possesses or satisfies the following 4 conditions or properties. Number one, the experiment consists of a fixed number of n identical trials. In other words, the experiment is repeated n times where n is a positive integer. So any statistical experiment must repeat n times, okay, or n identical trials. This is the first one. The second, the result of each trial can be classified into one or two categories, okay, one of two categories, success and failure. So each trial has only two outcomes. Okay, so the first property or first condition is n trials. The second is every trial gives two outcomes. Okay, so it's possible to reach one of the only two outcomes, okay, success or failure, right? The probability of success is denoted by P, and that of failure denoted by Q, where P and Q equal 1. P and Q remain constant for each trial. Okay, so the probability of success and the probability of failure must be constant from trial to another trial. Each trial of the experiment is independent of the other trials. So the outcomes or the outcome of one trial does not influence the outcomes of another trial. Notice that a success does not mean favorable or desirable, and also a failure does not mean unfavorable or undesirable outcome. The outcome to which the question refers is called a success. Okay, so if we want to compute, for example, the probability of success in an examination, you see that this probability means a success. But if you want to get the probability of failure in an exam, this probability is called also probability of success. So the word success doesn't mean the success itself, but the probability under questions, right? And the other is called a failure. The other probability is called the failure, okay? So the word success means the probability under question, not success itself. Example 8. Consider an experiment consists of 5 tosses of a coin. Determine whether or not it's a binomial experiment. 5 tosses here means n trials, and every trial will be head or tail, success or failure. One of two outcomes will done. Okay, so the solution will be this experiment possesses or satisfies or required conditions or properties of the binomial experiment as follows. There are 5 identical doses or trials, so n equal 5. Each toss or trial has only 2 possible outcomes, a hit or maybe success, and a tail or maybe a failure. So the label success and the failure according to the probability under question. The probability of obtaining a hit, the probability of obtaining a hit or success. So here, getting a hit is the probability that we ask about. So we call it success. The probability of hit is 1/2, and that of tail or failure is also 1/2. The total will be 1. For any toss, and the sum of them equal 1. P and Q equal 1. And Q equal 1 minus P. The tosses or trials are independent because the outcome of any toss has no affecting on the result of the other toss. So this experiment is a binomial experiment because it satisfies all conditions of the binomial. The binomial formula. How can you compute the probability according to the binomial distribution or binomial formula? This is the formula. F of R or P of R equal NCR, P power R, Q power N minus R. Okay? Look, if you get the summation of R and N minus R, the total will be N. Okay? So you divide N into 2 parts. One part which represents the power of P, and the other part represents the power of Q. Okay? And the total of P and Q equal 1. The total equal 1. Okay? So it's so easy formula to compute. N is the total number of trials. P is the probability of success. Q is the probability of failure, and the B equal Q equal 1 minus P. R is the number of successes in N trials. N minus R is the number of failures in N trials. To compute the probability of R successes in N trials for a binomial experiment, the only values needed are N and B. These values are called the binomial parameters. Okay? So the parameters of binomial distribution is N and B. And as we said, P is the probability of success, and N is the number of objects, the number of trials. Okay? They are the parameters of binomial distribution. Binom BDF. Binom BDF is a function to compute the probability density function of the binomial distribution. So binom from binomial, and BDF means probability density function. Probability density function. So binom BDF is a binomial probability density function. And the syntax is y equal binom BDF R N P. R, the trial of success. N is the total trial. P is the probability of success. So y equal binomial BDF R, N, and B computes the binomial BDF at each of the values in R using the corresponding number of trials in N and the probability of success for each trial in B and the R. Okay, N and the B can be vectors, matrices, or multidimensional arrays that all have the same size. Okay, example 9. Suppose that 5% of all TVs manufactured, TVs means televisions, manufactured by the national company in Egypt are defective. 5% are defective. Okay, 3 TVs are randomly selected from the production of this company. So we selected 3 TVs. Find the probability that exactly one of the 3 selected TVs is defective. So now we want to select 1 from 3. 1 from 3. How many ways you can select 1 from 3 defective TVs? By hand, and number of trials equal 3. R, the selected number is 1, and N minus R equal 3 minus 1 equal 2. Probability of success equal 5%. Probability of failure equal 95%. So P of R equal NR, P power R, Q power N minus R, or P of 1 equal 3C1 or 3-1 multiplied by 5% power 1 multiplied by 95% power 2. Right? Okay, this probability is 0.1354. By MATLAB, using the function binomial BDF, we have N equal 3, R equal 1, P equal 5%, then P of R equal binomial or binomial BDF, R, N, and B, R, N, and B. So the entries here begin with R, the number you want to select or to compute the probability, and the total number of trials, the probability of success. The same answer. Okay, the same answer. Binomial CDF. This is a cumulative distribution function. So binomial CDF, cumulative probability function or cumulative distribution function. Okay, this means binomial cumulative distribution function. Syntax: y equal binomial CDF, the same entries R and P. Okay, the second syntax is y equal binomial CDF, R and B, and upper. Upper here means the complement of probabilities to get 1. Okay, so this is localized 1 minus binomial BDF, 1 minus binomial BDF, or the summation of all binomial BDF. So it's better to use the type upper to get the complement probability you want to compute. The complement description. Binary CDF R, N, and B computes a binary CDF at each of the values in R using the corresponding number of trials in N and the probability of success for each trial. B. R and N and B can be vectors, matrices, or multidimensional arrays that are all the same size. Okay. Y equal Y minus the F, R, N, and the B. Upper returns the complement of the binomial CDF at each value in R. Okay. Example 10. DHL company provides high quality service to its customers. The company guarantees a refund of all charges if a package it is delivering does not arrive at its destination by the determined time. Okay, so this means that if a packet is not delivered on time, the refund will be done. Refund. Okay, it's known according to the past experience that 5% of the packages mailed through this company don't arrive at their destination on time. Assume that your faculty mails 10 packages through DHL company on a certain day. Find the probability that number A, exactly one of the 10 packages will not arrive on time. Number 2, at most one. At most one means 0 and 1 of the packages will not arrive at its destination time. Solution. By hand, and the number of all trials is 10. P, the probability of success is 5%, and the Q equal 95%. Number A, when R equal 1, then N minus R equal 9. So P of 1 equal 10C1 multiplied by 5% power 1, 95% power 9. The result is 0.315. When R equal at most 1, I mean 0 or 1, so N minus R equal 9 or 10. Okay, so Px equal to or less than 1 equal B of 0 and B of 1. Okay, so B of 0 equal 10 C0 multiplied by 5% power 0. You know that any number to the power 0 equal 1 multiplied by 95% power 10 plus 10C1 multiplied by 5% power 1 multiplied by 95% power 9. The result is 0.914. By MATLAB, using the function binomial and bino BDF and bino CDF, we have n equal 10 P equal 5%, R1 equal 1. So the first probability computed as bino BDF, R1, N and B equal 0.315. The second bino CDF, 1 here means at most 1, or 0 and 1, okay? N and B equal 0.9139. We can also compute the second probability by sum bino BDF instead of bino CDF, but it's better to use bino CDF, okay? So this is to ensure that the bino CDF is the summation of bino BDF. So you can say sum of bino BDF for 0 and 1, okay? Instead of 1 here, put 0 and 1, and N and B. So the same result will be, okay? But it's better to use bino CDF when the question is at most 1, at most 2, and so on. The shape of the binomial distribution, we will stop here and I will explain the shape of binomial distribution according to its parameter. I mean the number of trials and the probability of success. Thanks so much, and see you next week.